So it's saying in the parallelogram w, x, y, and z, what is cy, right? So in parallelogram w, x, y, z, or z, what is cy? And then they have a parallelogram here. I don't know if I can draw this nicely, but I will try my best. That's not very good. All right, that's the best I'm gonna do. And this is the point from the center, C, and this is Y. This here is W, and it's saying from here to here is x plus 4. X plus 4, and from here to here is 2x minus 7. It's kind of hard to see actually. So let me draw some arrows here. So this here is x plus 4 feet, and this here is 2x minus 7 feet. So what is cy is our question here. So take a moment to think about this question. In the parallelogram w, x, y, and z, what is cy? How would you determine what cy would be? Remember, you have to think about what defines a parallelogram in terms of lengths, in terms of angles. What defines a parallelogram? Because I'll give you a hint here. A parallelogram has opposite sides that are parallel. So these two sides are parallel, and basically it's a parallelogram has right angles that are all has angles that are which are not right angles, right? So if I have right angles here and here, it would be a rectangle. So remember, parallelograms here are the opposite sides are parallel, and opposite sides are also congruent. So they have equal length as well. The diagonals also bisect each other, right? So diagonals also bisect each other at this point here, at C here. So how would we solve for this problem? How would I find the length of this parallelogram? Well, let's work this problem out. If I know that my sides bisect each other, it means that I know that this length here equals this length here, right? WC has to equal CY here, right? To make this assumption work, right? So if I say that WC equals CY, then I can make the expression I have x plus 4 equals, or I don't need the brackets actually. So it says here x plus 4 equals, this is 2x minus 7, right? What I can do is then I can simply just I'll rearrange for this for x and sub x back into our equation, right? To see which value x satisfies for this equation here. So let's do it, right? I can collect my like terms, so I can move 2x to my other side, my left side here. So I have x minus 2x, right? Which here would be negative x. And if I move plus 4 to the other side, I would have negative 4 minus 4. So I have negative x equals negative 4 minus 4 would give me negative 11. And the x would simply, if I divide both sides by negative 1, I would get 11 here. So x equals 11. And what I can do is I can sub x equals 11 back into my equation for, I want cy, right, for this here. So I have 2x minus 7 is equals to cy, right? So cy equals 2x minus 7, and then cy equals 2 times 11 minus 7. So 2 times 11 is 22 minus 7. This here equals 14. So, 15. And this here is my correct answer for cy here. What's cy? Cy here is 15 feet. So let's look at the solution here. Since the digital diagonals of parallelogram bisect each other, therefore C is the midpoint, which means that I know that from here WC equals CY, and that's what I did this here. They did the exact same thing. They took all their variables, they rearranged this equation to solve for x here. X equals 11, which is good, and therefore they plugged this back into the equation, and they got x here equals, or CY here equals 15 feet. So this here is correct. I don't really like how they didn't really show how they rearranged it, whereas I kind of showed my work here. So I'm going to say this is a good solution, or great solution, but show work for the equation 2x. Actually, they did show work. Actually, from here to here they did show work. So actually let me just not put that. I'll just say great solution and analysis. Solution here is correct.